Okay, for today's integral, we have the integral from 1 to 2 of x to the power of x squared plus 1, all multiplied by 2 ln of x plus 1. Now, as soon as I saw this term, x to the x squared plus 1, I recognized that there was x to the power of x, and when I see that, I think logarithmic differentiation. So I wasn't exactly sure what function to differentiate, so I just messed around with a few functions, and I came up with we should use y equals x to the x squared. Now, to differentiate this, it's not exactly obvious. When there is x to the power of x, there's not exactly a formula for that. So what we do is we take the natural log of both sides first. So ln of y equals ln of x to the x squared. Now we could simplify this right-hand side using our first formula up here, ln of a to the b equals a ln b. So ln y will stay the same. But the right-hand side, we could rewrite ln of x to the x squared as x squared ln of x. Now we can differentiate this easily. Ln of y differentiated, that's going to be 1 over y multiplied by dy dx. And on the right-hand side, we'll use the product rule. So that will give us 2x ln x plus, it will give us, this differentiated will give us x squared over x, but we can just simplify that right now. That will just be x. Before we continue, I'm going to factor out an x on the right-hand side. So that will give us x times 2 ln x plus 1. Now we want to isolate dy dx, and to do that, we'll multiply both sides by y. So dy dx will be equal to xy times 2 ln x plus 1. And we want to now return this all into form of x, and we have this y here, but that's actually not going to be a problem to turn to x, because up here we actually have a value for y in terms of x. So if we plug this back in down here, that'll give us dy dx equals x times x to the x squared, all multiplied by 2 ln x plus 1. We want to combine these two x terms now, and we can use our second property here, x to the a, x to the b equals x to the a plus b. And so finally, for our derivative, we will have dy dx equals x to the x squared plus 1 multiplied by 2 ln x plus 1. Now if you notice, this is the derivative of this function right here. The derivative of this function is the same as the integrand of our integral. So because the derivative is the same as the integrand, then that means that if we integrate this, we will get this function. So the antiderivative of this integral is just going to be x to the x squared. And we just have to plug in our balance, so it's from 1 to 2. That will give us 2 to the 2 squared minus 1 to the 1 squared. This part is equal to 16, and this part is equal to 1. So 16 minus 1, basic arithmetic, is just 15. And that is our answer.